Hi everyone, my name is Garten Lau, and I would like to present the paper Deep Clustering for Unsupervised Learning of Visual Features, which is published in ECCV conference in 2018. Firstly, I would like to talk about the problem. As we all know, pre-trained CNN with large-scale datasets produce excellent general-purpose features for transfer learning. However, the size of the most common large-scale datasets, which is ImageNet, is relatively small by today's standards. And we can improve that by building a larger and more diverse datasets. However, this would require a tremendous amount of manual annotations for labeling. Therefore, the need of a method that allows us to train models with no supervision is necessary. At the same time, unsupervised learning, especially clustering, is a possible approach for visual feature learning, but Littlewood adapts clustering to the end-to-end training on large-scale datasets. In this paper, the author proposes a method called deep cluster to alternate between clustering and parameter updating to learn the visual features. Here is the pipeline of deep cluster. Firstly, unlabeled images from ImageNet will be applied augmentations and then fed into a CNN, which is the AlexNet architecture used in this paper to extract the features. And then the PCA techniques is then used to reduce the dimensions of the features along with the L2 normalizations. After that, the processed features are passed to the k-means clustering to get the cluster assignments for its image. The clustering is obtained by optimizing the objective function as shown here in the slide. And these cluster assignments are then used as the pseudo labels for the CNN. And then we continue to train the CNN to predict the labels with a classification task using the gross entropy loss. Here are some visualization results from the cluster. The author assesses the quality of some target features by learning a synthetic image that maximizes the feature activations and extract top 9 activated images that cause the highest activations. And the slideshow results images for target feature in layer 1, layer 3, and layer 5. And from the results, we can see that by using the cluster, the layer can capture some textural structures, and the deeper the layer are, the larger and more complicated textural structures can be captured. The author also conducts 3 different tasks, including image classification, object detection, and segmentations on the Pascal VOC datasets, and compare the performance of deep cluster with fully supervised settings and with others unsupervised methods that already published. And the table here summarizes the comparison results. Here FC68 denote the case we only train the fully connected layers and freeze other layers before the fully connected layers, and OR here mean we unfreeze other layers for fine-tuning. And the results show that deep cluster outperform all the previous unsupervised methods on all 3 tasks in every setting. And in object detection tasks, deep cluster performs slightly better than other unsupervised methods, but in the segmentation task, we can see a largest improvement over the state-of-the-art. And the result also show that by using deep cluster, we can reduce the gaps of performance with the network trained in supervised learning manner. Here are some conclusions that we can test from the paper. Firstly, the paper proposes a scalable clustering approach called deep cluster for the unsupervised learning of CNN, and deep cluster can achieve significantly better performance than the previous state-of-the-art on every standard transfer task when trained on large-scale datasets. And about the applications, the cluster can be applied to visual feature learning for scenarios where annotated data are scarce. Thank you very much and good luck.